All right. So here's how I'd mark this up. Equal out triangle, right? Why am I marking it like that?
All equal.
They're all equal, yeah. Yeah, all of them are equal, yeah. Yeah, I'm just gonna change my vantage point because I get bored staying that way. I want to get away from Maggie. All right. Just kidding. I'll be closer to the computer here. No. Yeah, you just do that, right? So let's look at isosceles triangle. How many sides are the same? So I'll do that. Now, will I do any markings for the other two triangles? No, no markings here. But if it's a right triangle, probably a good idea to do that.
Thought for scaling, do like, isn't it like none of the sides are equal? So
Actually, you know what?
one.
You know, Reagan, you're right.
You all know how.
Yeah, actually, you're right. Well, actually, and you know what? It's good forward thinking because the reason why we want to do that, eventually we're going to compare these triangles to other triangles. So, like for example, like what if I drew a second triangle somewhere off to the side here? I said, oh, this isosceles triangle, well, it's not obviously the scale. It's the same as this one. So, for example, if I were to call this like ABC and call this DEF, actually, I'm glad you brought that up because if you think about it, what side is the same as AC? Yeah. And then AB is the same as DE, and BC is the same as EF because they correspond. So actually, yes, we do want to do that. So I got a little lazy there. Yes, we should actually mark up all the sides. But if sides are the same, you use the same markings. If they're different, of course, give it a new marking. So for scaling, yes, 1 mark, 2 marks, 3 marks. And for this one, 1 mark, 2 marks, 3 marks. And where you put them exactly doesn't really matter. But yes, we should do that. 100%. Okay, isosceles and a right triangle. So this definitely has a right angle. Isosceles means that two sides are the same. Which two sides would be the same? Yep, the horizontal and vertical. And the hypotenuse obviously is its own length. Oh, they're good. We will do that in a moment. I don't want to make it too busy. Yes, we should do that also. How about a square? All of them are the same. Yep. Rectangle's right done for us. Yes, I should do that also. I'm gonna come back and do the angles. Yeah. But yes, yes. Actually, you know what? Since you brought it up. Yes, I should do that. Oh, so you had a question?
Oh.
No, yeah. Okay. Um, okay, so rectangle, yeah, all the right angles are put, all the sides. And by the way, if sides are parallel, you also put these little arrows, if you want to call them that. So just because there's too much going on with that square now. But you'd also want to do this, right? Now, what does that mean when I do this? Yep, parallel. The top bottom parallel, left and right parallel. So the arrows are stand for parallel. No, but it's just more we have to just understand these markings. I think you have to know how to classify these. I mean, we'll talk about that. Parallelogram. Um, these are the same, and these are the same. And not just they're the same, they're also parallel. I know it's very, very tiny. So do that. Oh goodness. I did not leave myself no space, did I? You have that as well. So you have two pairs. And if we look at the next page, um, actually at the Ansky here. Next page kind of provides all those finer details. Yeah, quadrilateral, two pairs of parallel sides, and also congruent too. They're also congruent. Rectangle, quadrilateral, 4 right angles. Square, quadrilateral, 4 right angles, 4 equal sides. Blah blah blah, all that stuff. If I look at the angles, let's talk about angles. You mark it like that. that's like 3 markings. Oh goodness, this is getting really challenging. Too small. If you have right angle, could just stand alone as right angle. That's totally fine. You know, it's not the same as the others. These are the same. Those things. So we use these little like crescent type markings, if that makes sense. And of course, 1, 1, 2, 2, whatever. Okay, so we're okay. It's good. Yeah, cool. All right. Okay, a trapezoid. All I really know, I'm just gonna zoom in now because this is just driving me nuts. It's just so tiny. Trapezoid, you only have 1 pair of parallel sides. That's it. It's not that special. Just that. That's all we know. Rhombus is like a diamond. All sides are the same. Quadrilateral, all of them are different. It's not special. Hmm? Correct. Yes, that is correct. So let me do different colors for that. Thank you for bringing that up, Faith. Yeah, so you have this, and then double double. Kite, nothing's parallel, but these are the same, and those are the same. Obviously these are different for the trapezoid. By the way, sometimes you can have a trapezoid where these are the same. The slanted sides. If those are the same, we call it an isosceles trapezoid, which is right actually down here. Speaking of. So those are still parallel, but now those are the same. And of course, these 2 sides are not the same. A circle, it's not a polygon. What do you call this segment I just drew? There you go. That's it. Yep. And what do you call this middle point here? That's the center. It's the center of the circle. That's it. And what's true about a circle? It's a set of points of equal distance to a fixed point. The set of points are all the points in the circle. The fixed point is the center. And what's that distance? It's the radius, exactly. That's all center of a circle ever is. Regular always means all sides and angles are the same. Okay, all sides angles are the same. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Hexagon 6. Don't worry, you don't have to memorize. I mean, should know pent and hex. Don't have to go beyond that. All the angles inside are the same as well. We'll talk about those measures in a later time. So you have that. Actually, you could probably figure that out. Let's talk about that actually, really quickly. You could figure this out. You could use some intuition. So say I ask you, what's the measure of this angle here, right? Like, I don't know. You can figure it out. It's not that hard. Draw center. Cut this up equally. Think about it. If I go around all the way once, how many degrees is that rotation? And how many different triangles do I make? So what are you gonna do? Just divide by 6. Okay, so if I look at one of these little triangles, so that guy right there is 60 degrees, right? Okay, what can you say about these 2 sides here? They're the same. How many degrees in a triangle? Close, 180. So how much is left over for this bottom 2? If you split them equally. So you split 120 equally. There you go. What kind of triangle did I make? There you go, equilateral. And so if that's 60 and that's 60, now I know this angle here is gonna be 120. Because it's a combination of both those triangles. Because remember, there was another triangle just like this right here. So you could totally figure, but these are things we'll talk about later in the year. But if you use a lot of logic, yeah, this stuff's not really. So we want to get away from memorization for math. You know, if you've been learning math by memorization, that's not really the best way to learn math, to be honest with you. You really want to understand stuff. So that's a great way of understanding why these things work the way they do. Just visualize it. It's using intuition comes out really nicely. Okay, so I think I kind of beat a lot of that to death. I think we got a lot of that out of the way. By the way, these are the same. Forgot to say that. Those are the same. Obviously, all these angles are different. If you wanted to mark that up, you could. It gets to be really messy after a while. But on the next page, you'll see, yeah, for most parts, it's kind of doctored up or it's explained, all those things. Okay. So we're good on all that? Cool. All right. So may have went off script with these notes. Let's find out. But I want to have that discussion. All right. So again, marking right angles, as we know how to do that. There's a rectangle, there's a trapezoid, blah, 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 whatever. Label, just did it. Actually, that was a different one. I don't know. Anyway, this is what we really want to work on today. We want to work on classifying and finding overlaps. So I'll do one of these with you guys. And then what I'll probably ask you guys to do is to get a device afterwards and click on these links, because this actually takes you to Desmos and has a kind of a nice visual with a Venn diagram. So let's look at this one here. The following links will be sent to you by your teacher. You guys just go to Schoology and access these notes. I'll show you where you can access them. So if I click on this, okay. Oh, this is fun. All right, so this is where you guys have to play at this. You have to move shapes around. This is a cool little, and this is the first time I'm actually playing with this, so I might mess up. So if I mess up, I'm sorry. Anyway, what are we looking at? So you guys know how Venn diagram works? Yeah, very simple. You have two circles, they have an overlap. Overlapping means it has to have both those conditions, right? So so for example, like you could say, like, I don't know, I'm trying to think of a good example. So it'll take me for example, right? Okay, so more than 40 years old and male. So obviously I'd be right there, right? Okay, if I look at my wife, she's not male, but she's older than 40. She's right there, right? If I look at my son, he's 8. He's right there, right? But I'm in the middle because I fit both those conditions, right? I'm older than 40 years old and I'm male, right? So so kind of the same thing here, right? Has at least one pair of parallel sides, has at least two sides of equal length. Okay. So let's look at like this one right here. So does it have a pair of parallel sides? No. Does it have two sides of equal length? I'd say probably it does. So I'm gonna drag that in here. Now let's look at this one. There's a square, right? Does a square have at least one pair of parallel sides? Does it have at least two sides of equal length? So I'm gonna put that probably in the middle. Okay, that's a rhombus. Does it have at least one pair of parallel sides? Does it have at least two sides of equal length? Put it right here. This is we're gonna be assessing this on our test. So we want to make sure you guys are comfortable. You're gonna have plenty of practice after I finish this. Let's look at the parallelogram. Where do you think that's gonna go? Okay. By the way, some of these might be left out. Some of these might be left out in the cold. They don't belong. It's sad. Everyone should belong, but that might happen. How about this with the red hexagon? Middle. I like it. Middle. How about the trapezoid? Does it have any equal sides? Actually, it's yeah, it does go in the middle. Actually, yeah. Yeah, you guys are right, yeah. But how about this trapezoid? Yeah, probably right here. Yeah. It's not special. Sorry, dude. You go outside. All right. So sad. That's gonna be probably over here. Yep. Nope. Probably in the middle.
Wait,
Yeah, it says.
Parallel. You are right. You are correct. Thank you. Yes, I messed up there. Okay, this one should be in the middle. That one, you're not special. I know. This one's kind of special.
equals.
Yep. Yeah, I think we've. And then this is an isosceles triangle. So it should go right there. I feel like. Yeah, no, this is correct. Oh, the answer key is off a little bit because I actually had this one outside. That's not true. Okay. Yeah, this answer key is off a little bit. Okay, that's why I was a little thrown off. I think we got it right. I think we're good. All right, so what you're gonna do is if you go to so get out of the laptop, go to class handouts. And at the bottom, you'll see Venn diagram, BCD. We're today together. Click on BCD. It'll take you to the Desmos link. And you're just going to do that. You're just going to classify these. And that's pretty much our notes for today. Actually, once everyone's done, there's like one last thing on the notes we'll talk about. But yeah. Go to class handouts. Yes, all three. Yes. So you're not really taking this, you're just using your laptop. You're just kind of move shapes around. That's what you're doing. No, you already did it. You don't have to do it again. Just do BCD. Yeah, just do BCD. And I do have now that I don't know if I really trust this answer key. So you know what? I'll do it too with you guys. I'm not gonna get lazy. I should do it also. Sure, go. Yeah, yeah. Yeah, I'll let go. Hold on. Let me see here. Let's see. Sliders off.
Well, I think they like. No, it's different,
Oh yeah, sorry, my apologies. So I should see this is what happens when I do the notes for the first time. So now there's a new categories. Not the same categories before. What are the categories here? 3 sides and a right angle. And then I think then when you do the next Venn diagram, that's gonna be I think on symmetry.
Should we take a photo when we're done, or like what do we do when we're done?
You don't have to take photos, fine. Oh, click on here. Class handouts. And scroll down, you should find it right there. There we go. And then if you want to go directly to the link, just do that. There we go. Yeah. You should have Desmos open. I do have the answer key in actually, you know what? The answer key is in Schoology. So you don't have to record your results. It's there for you to check. So the answer key is in Schoology. But I now look at the first answer key. I don't agree with it fully, but yeah. Let's make sure everyone is comfortable with navigating this. It's don't worry about that. Just yeah, don't worry about that.
Wait, is it on the site? Do they have a right angle?
I'm sorry, say again.
Great.
That doesn't have right angle. No, I mean it's what we shouldn't trust that these are employed to scale,
Okay.
but I think we have to in some ways.
On the test, will like give you the.
We'll say the actual like shapes, like we'll specify, oh, here's a rhombus, here's a rectangle.
And you just have to.
Correct, so that's what you have, the reference sheets.
Okay.
So guys, the reference sheet that, you know, with how these things behave is on the back side of your notes here. No, let's move on to the next one. Actually, If you want to save, can you guys save a copy?
Mhm.
Yeah.
You know what? Go ahead. If you want to save, yeah, go ahead. Yeah. I mean, the answer's already in Schoology, just so you know.
Where are the answers?
If you click on the notes, so let's go here, class handout notes. It should be space, sorry, space. I'm spacing out. Shapes toolkit key. Here it is. It's not.
Same.
It let me save a copy.
Oh, wait 1 sec. You are correct. Oh, you know what? Reagan, I lied to you. It's actually the 1-3 answer key, which is I thought here. Yeah, wait, no. Okay, I gotta talk to Mr. Dave. Wait.
Is it okay if we stop?
Yeah, you don't have to save, it's fine. Yeah, I did. Well, let me put the answer key up then. Wait, let me see here.
I wasn't gonna let you save this.
It's all right. Don't worry about it. No.
So just like do it and then leave.
Correct, yeah.
I've done two.
Let me upload the answer key. Hold on. Let me do it right now. Thought I had it up here. Oh, here we go. Let's wait after few more minutes because we go to 9:40, so we're okay. But thank you for reminding me. I almost forgot. Yeah. So obviously for this, so let me show you the answer key because I'm gonna get a little lazy here. Okay. So I did put the answer key in Schoology. So you guys have access to this. Don't worry. You do have the access to the answer key. It's in Schoology now. You guys get that? Yeah, that makes sense, right? It has 3 sides, but it has a right angle. Only 2 of them satisfy both. And only 3 are just right angle situations. So hopefully you got that. So going to do C next. I'll do C with you guys. So reflection, symmetry, and 180. I probably put this one here. Would you guys agree? Yeah. Probably square would have both. Yeah. ROM is probably would have both. I'd say. Yeah. Okay. How about the Pentagon? Whoa, I don't want what's going on there? Okay, probably just here. Oh goodness, no, I don't want what is this about? Oh my gosh, that's terrible. What? This is crazy. What's this news story? University of Kentucky. Oh my goodness, we don't even need terrible news. All right, I didn't even need to click on that. Anyhow, that should be. Hold on, just rotation, yeah. Hex. Yeah. Hexagon has both. This one should, if it's isosceles, just have reflection. Triangles, just reflection. It does have symmetry, by the way. Sorry. The triangle does have rotation symmetry, but it's not 180. What's the rotation symmetry for the triangle? If it's three sides, 360, 120. Yeah, that's 120, not 180. The rectangle has both. That's not special. That's not special. That's not special either. That's not special. That's not special. That does have reflection symmetry. That should have reflection symmetry. So it looks like I have 6 shapes. Everything else I think seems a-okay. Yeah. Okay. We're okay with that? Yeah, Sanskis, I gotta talk to this because they have the parallelogram in the middle. That makes no sense. I wouldn't put the parallelogram in the middle. All right, last one. Go and try D. And then we'll have a little discussion about the last question on 122. Then we're done with the notes. All right, see here. Reagan, Megan, Maggie, sorry, you guys can. Yeah, I know. No worries, it's all good. It's Friday. This is Thursday. I wish it was Friday. Sorry. Thought today was Friday. Oh my gosh. I'm just losing it today. All right. Okay. Quadrilateral and equilateral. So those that are so there's only gonna be 2 that go in the middle. Which 2 go in the middle here?
Wait,
Square,
Not one thing.
rhombus. Equilateral, just straight up just equilateral. The hexagon, the pentagon, and
Okay, no.
No.
the rectangle goes here. Those are all quadrilaterals. Just off to the side. Which is here. So 4 triangles that sit on the outside. Whole bunch on the left. Okay, the Ansky is I do agree with this Ansky. This Ansky is correct. That's good. So you should get that. So really, it's just a matter of common sense, if that makes sense. I don't know. Like just 4 sides, but if it's equilateral and 4 sides, put it in the middle. If it's just equilateral, put it in the far right. If it's none of those 2, leave it alone. So, okay, good on that. All right. Go, Maggie.
Oh, wait.
You good? Okay, cool. All right, then lastly, the last part of the notes. Here we go. Okay, what is going on? Oh my, this is terrible, terrible news. What is going on here? I don't know why I click. Okay, I gotta turn this off. All right. Now, I think my career is slow. It's clicking on random crap. All right, here we go. Okay, last part. All right. So let's have someone read this last part. You want to read it, Kara? Go ahead. Yeah. Mhm.
It turns out that only shape in the shape bucket that could go in the intersection where the 2 circles overlap is a square. What are the possible attributes that your circle could represent? Discuss this with your team and be ready to share your ideas with the class.
Okay, so we'll just do this as a whole class. What could be the potential categories? Now you're working backwards. Before you're given the categories. So Connor, you have an idea? Ooh, I like that. So quad and at least 1 pair of parallel sides. Sure. Or actually, let me rephrase that.
yeah, I agree.
Wait, 2. You said parallel sides,
Could be a rock.
but it could be a rectangle too, right? All sides are parallel. So let's go through doing. Let's say hold on. Let's rephrase this. Actually, you could add a condition, make it more, but then I'm adding 2 conditions in it. Actually, if we want, correct. But what if I did this, equilateral and equal angles? If I made a third circle, I could do that. I want to make it more complicated, but I like equilateral, but rhombus would fit in that as well. So I don't know if that would really be best for us. We could say equilateral with right angles. So if we extend that a little bit, maybe that could work. So that's a potential possibility. Or we could say right angles. Okay, I just said that, right angles equilateral. So I'm repeating myself. Did I just say that? Right angles equilateral? Yeah, I did say that. Oh, actually, yeah, that's even better. Yeah, let's say equilateral. No, I didn't say it. Yeah, I'm not going crazy. Equilateral and right angles. Yeah, that could work because a rectangle would not be in the middle. No. And and all other equilateral ones, the triangle, the pentagon, the hexagon would not go in the middle. Yeah, I like that actually. That's a better one. So I'd definitely put like a triangle here and maybe a hexagon or a pentagon. I'm not drawing very nicely. But here I just do that, or maybe kind of this random little thing there, perhaps. But yeah, that could work. So, all right, good. Okay, I think we're all set. The rest of the class, we got like another 17 minutes. I say just use this time to start studying. So you want to work on the that packet, the Unit 1 review, do that. If you do have something that's more pressing for another class that you really want to work on, I'm totally okay with that. I won't be offended. Like if you have like a history test coming up like later today or a quiz, you need to do that. That's totally fine. I'm okay with that. But it's just time to work, ask questions, look at your notes, yes, yeah. And then so it's starting the quizzes. So
Are these two just resting?
yep. Do you want to take me here? You want to go to a little study hall or? Okay, yeah, just wider.
Yeah, all you think. I said it's embarrassing, and then how about it?
Oh, yeah, go, yeah.
Sweet, so I told her about. Yeah, she has this one, it's like. But I can't find the same pattern. Oh, me, oh, I love this. I have to read. No.